Hello, Math 133 students. I've received a request for help with this question, which is 4.2.24t. All right, so I'm going to click View an Example. I'll do the example, which will, of course, be very similar to the problem. An engineer wants to determine how the weight of a gas-powered car X affects the gas mileage Y. The accompanying data represent the weights of various domestic cars and their miles per gallon in the city for the most recent model year. Complete parts A through D below. So part A wants the least squares regression line. So I'm going to click on the table to view the table. And then over here on the right, there's like a little icon that allows me to click on that and I can open it in StatCrunch, which is exactly what I'm going to do. It's checking my credentials, but I have already logged into StatCrunch. That's why it has my name over there on the right corner. Okay, so for regression, we want to go to Stat, Regression, Simple Linear. The X variable is the weight. The Y variable is the miles per gallon. And I'm going to click Compute. And the regression equation is right there. It's a little icky because of the way they did this. So just to make it clearer for you all, let me close that. I'm going to get rid of this weight business and this pounds. I'm just going to call it X. so that way you can see it more easily. Because whatever you put up there in StatCrunch for the title of the column, it will actually do that. So let me do that again. Stat, regression, simple linear. It's going to give me the same answer, but it'll be a little bit easier for you to understand. There it is, right there. So the regression equation is right there. Y equals 44.64631 minus 0.0069 blah, 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 X. Okay, so let me go back to StatCrunch. That's the equation. They probably only want like 3 decimal places or something. So I would say done over here and click continue, continue. Fine. There you have it. Same equation that I came up with, right? So they want, say round the X coefficient to 5 decimal places as needed, round the constant to 1 decimal place as needed. See how they wrote it in the background? Okay, so we would do 5 decimal places for the slope, and we do just 1 decimal place, so 44.6. Then interpret the slope and the y-intercept if appropriate. Okay, so let me type this up 1 second. Okay, I made a Google document here. So for part A, it was the regression equation. So that's that piece right there. And again, they wanted only 1 decimal place here, and they wanted, I think it was, oh, I went too far. Stop. They wanted several decimal places here, so I think it went to 8 right there. Okay, and again, you can write this the other way. So you could say y equals negative 0.00698x plus 44.6. The order doesn't matter as long as the one with the 5 decimal places stays with the x. That's multiplication. And then the 44.6 is by itself. StatCrunch writes it this direction, and then algebra class usually writes it this direction. So either way is perfectly fine. All right, so next they want us to interpret the slope. Okay, so the slope says that on average, if I could spell, if x increases by 1 unit, then y increases or decreases. In this case, it's going to be a decreases by 0.00698. Now that's not sufficient because for a variety of reasons. One is that I don't actually have what x and y were. And I deleted it because it made it hard for us to understand. So we have to go back and look at it. So x was the weight. And the unit is pounds. And then y was the gas mileage in miles per gallon. So we would have to put the units back in. So we'd say if the weight of a car increases by 1, and then unit would be pound, then the gas mileage, oops, I spelled mileage wrong, decreases by 0.00698 miles per gallon. And it just occurred to me that's very small. Let me increase my zoom factor so you can all see that better. There you go. There you have it. Okay, now what about the y-intercept? Well, the y-intercept actually doesn't make sense in this case. So, and that's because think about what the y-intercept is. Oh, I should say the slope. The slope was the 0.00698. That's the slope, negative, right? That's why I used the word decreases here, because it was negative. So that was the slope right there. The y-intercept, let me just say what the y-intercept is. The y-intercept is always 0, comma, right? Because it has to be, because it's a point on the y-axis. So the x value is 0, and it would be 44.6. So it's a point. And the problem, as per usual, is the 0. The weight of a car cannot be 0, right? It wouldn't exist. So the weight of a car cannot be 0. That would mean the car does not exist. Technically it's pounds, but there we have it. I'm just going to make these all bigger fonts so you can see them better. All right, so let's go back to what my stat lab says, and let's read. So continue, sure, blah, blah. Yeah, so the interpreter says it is reasonable to suggest that the gas mileage changes with the car weight. A heavier car will take more power. Oh, so they're keeping it really vague. Got it. All right, so they didn't do the formal script piece, which I did. So if you think about what this is saying if a car weighs more, right, if its weight increases, then its gas mileage decreases. The heavier a car is, so in other words, the heavier the car is, the lower its gas mileage, which anybody who's ever shopped for cars knows that's true, right? Heavy cars don't get good gas mileage. And then letter C, there's going to say that you can't have, right, a car that weighs 0 doesn't make sense. Perfect. All right. There we go. So 0 is not reasonable. It's not appropriate to, yeah, there are no observations anywhere close to 0, of course. I mean, these are cars. So they all had weights in the thousands. All right, so then a certain gas-powered vehicle weighs 3,800 pounds and gets 20 miles per gallon. Is the miles per gallon above average or below average for this car's weight? Okay, so let me highlight that and copy and paste it into my document so you guys can see it. A certain gas-powered car, that should say car, or vehicle, whatever, weighs 3,800 pounds and gets 200 miles to the gallon. Is it above or below what we would expect? Okay, so first thing I have to do is figure out what we expect. So I have to find y hat. So let me insert an equation in here. Oh, actually, let me copy and paste it. Either one will work. I'll take this one. So that's my equation, but instead of x, I'm going to put the weight, because x was the weight of the car. So I'm going to take 3,800 and I'm going to paste it in there. And I am going to try to copy and paste this into Desmos. So, hold on, I was showing something in class in Desmos. Ha, there we go, copied and pasted right out of there into Desmos. So they think it's 18.076. So 18.076, and that would be miles per gallon. Okay, so then we expect it. So this is the average, right? This is what we expect. It's our prediction. And then what it actually was 20 miles per gallon. So then the next question they're saying is the miles per gallon of this car above average or below average? Well, average would have been 18.076. So we are above average. So this car is above average because 20 miles per gallon is more than 18.076 miles per gallon. Right? The average is the line, right? The regression line. All right, so then let's go back to the question and see what else they want. Oh, they're going to come up with the same thing I did. So I can prove to you that my answer is correct because there it was. So we were above average. Would it be reasonable to use the least squares regression line to predict the miles per gallon of a hybrid car and electric car? Why or why not? Oh, no, that would not be good. So if you remember, this entire data set was gas-powered cars, all of it, right? The whole thing was gas-powered cars. So it would not be appropriate because hybrid cars and electric cars are completely different things. So we couldn't possibly use the gas mileage for gas-powered cars to predict hybrid cars and electric cars. They're completely different data sets. So the answer, let me highlight that and put that in there. Okay, so technically this was letter D. So letter C is gone. Letter C that was all part of B. All right, so D. Would this be appropriate or not? And the answer is no. Oop. Oh my goodness. Sorry, I'm trying to make this big enough you guys can see it. So it would not be appropriate because our entire data set was gas-powered cars. We would have to gather data on hybrid or electric cars to make those kinds of predictions. I don't know how they're going to write it for the particular problem you're looking at, but it should be something like that. And down here in the example, they're saying, carefully consider that this was not, that your data set didn't have any hybrid cars, right? If you want to do hybrid cars, that's one thing. If you want to do electric cars, that's another thing. You can't compare apples to oranges. So there we go. All right, I hope that helps.